Hi everyone, we're going to go ahead and get started on this review. Now remember, if you're completing this review, it is because you scored a 70 or below a 70% on the last summative, and you want to do this to retake that summative. If you're retaking it, you need to retake it after school on Tuesday or Wednesday, or during lunch on Wednesday. Those are my only opportunities for retake. Right, so let's get started. I would suggest that every time I do one of these, you just watch me work through it, pause the video, and try it on your own on a separate sheet of paper or a blank review if you picked up one of those. All right, let's get started. So Miss Mendez surveys her class about their siblings in class, and 80% of them have a brother, 75% of them have a sister, and 60% have both a brother and a sister. So when we're working this out, remember first off to turn all your percents to decimals. Right, so let's go ahead and build this from the inside out. The ones that have both are 0.6. The ones that just have a brother is, well, it's 80% or 8/10. And here I am going to put 2/10. Then for a sister, ones that already or have a brother as well are accounted for, what I've got left over is 1/1500. Now that gives me a total of 95%, which means that I'm left with 5% who don't have a brother or a sister, so they're an only child. Now looking at numbers 1 through 4, these are either going to be and or statements that we need to look at. So the formula that we're using is right here. What is the probability that a student has a brother or a sister? As soon as we've seen the term or, we are using that entire formula. So the probability of a brother is 8/10 plus the probability of a sister is 7500 minus the probability that they have both. And that gives me 9500. What is the probability that a student has a brother and a sister? That is 6/10 or 60%. What is the probability of a complement of the intersection of the brother and sister? Remember, complement means everything but not that. So considering that it's everything, not the intersection. So that would be 40% or 4/10. What is the probability of the complement of the union of a brother and sister? So they want nothing to do with any brothers or sisters. In this case, that is remaining of 5%. All right, so go ahead and pause the video, look back at what we just did, and make sense of that. Write down any questions you might have that you have to review with me before you take this summative. All right, let's go down to number 5. Suppose that out of 800 cars parked on the beach, 220 of them are compact, 150 are blue cars, and 75 are both compact and blue. What is the probability that a car selected at random would be compact or blue? There's that key word again then when it comes to or. So when we're looking at or, and we are not looking at percents, that means we're going to be writing these probabilities as fractions. So the probability that they are compact would be 220 out of the 800 cars, added to the probability that they are blue, which is 150 out of the 800 cars, minus the probability that they are blue and compact, which would be 75 out of 800. All right, so now when we have that, and that gives us 295 out of 800, and then make sure that you reduce that. One of the biggest things that I've seen on this test is that people were not simplifying the fractions. If you don't simplifying, that is incorrect because the instructions say to simplify. So make sure that you reduce that. Again, if you need help on how to reduce that, or if you're trying to figure out how to do it in your calculator, please make sure that you ask me that before doing this retake. All right, next one, number 6. A coin is tossed and a 6-sided die is rolled. So here we have two events happening, two different events that we have to take into consideration. What is the probability of the coin landing on tails and rolling a die? Now, when we have two events, we're no longer adding the events and subtracting where they overlap. Instead, we're multiplying the probability of each event. And since each event is not in a percent, we're going to have to write them as fractions. Okay, so this is where they are either going to be mutually exclusive or inclusive, so let's pay attention to that. A coin is tossed. That is a 1 out of 2 probability if I wanted to get tails. Okay. And this is going to be an exclusive event because the coin has nothing to do with the die. Now, a die, it has 6 sides, and they want to know a number that is greater than 4. There's 2 numbers that are greater than 4, so that would be 2 out of 6. Multiply those straight across. You could reduce this fraction to 1/3. I'm just going to go ahead and multiply straight across so that I get 2 out of 12. And then again, make sure that you write that as a simplified fraction as your answer. All right, now number 7, a bag of marbles has 4 red, 3 blue, 2 yellow, and 4 green. 3 of the marbles are randomly selected from the bag and not to replace. This is important. Find the probability that the first one is red, the second one is red, and the third one is yellow. So this one here, we are using the probability of A times the probability of B given A already occurred. All right, remember this vertical line here means given. So looking at this one, the probability of A, what is the probability that the first one is red? Well, there's 4 red marbles in the bag out of a total of 7, 9, 13. Well, we don't replace that marble, so the second time that we go to draw a marble from that same bag, now there are 12 marbles in the bag. And instead of being 4 red, there's only 3 red replaced, or 3 reds that still exist because we took that first one out. Now for the third event, now we've got 11 marbles left over, and there's 2 yellow ones in the bag, so this is out of 2. Now in this case, I'm going to go ahead and reduce so these numbers aren't so large. I can see that 3 over 12 can be reduced to 1 over 4. Now remember, your calculator can do all of this for you. So you could actually just type in those fractions right there, and you would actually get the complete reduced answer. So 4 times 1 times 2 gives me 8. And then we do 13 times 4 times 11. And that will give me 572. Again, make sure that is a simplified fraction. You'd still want to put that in your calculator if you were using that as your tool to make sure that couldn't be reduced any further. All right, number 8. Now here's where I saw a lot of mistakes on this one. On this one here, you're not just identifying whether it is independent or dependent based on what you read. You actually need to use the formula, okay? So suppose that it is known that 60% of high school students are Harry Potter fans, 40% are Twilight fans, and 28% are fans of both. Are these events independent, yes or no? And then prove it. So I'm going to start with the prove it before I select my answer of yes or no. So if it's equal, then it's independent. If it's not equal, then it's dependent. So for Harry Potter, that is 6/10. For Twilight, that is 4/10. And for both, that is 28/100. Okay? All right, so the probability of A is 6/10 times 4/10. And does that equal 28/100? This is not a true statement, so this is not independent. All right, going down for number 9 through 13, we are going to do these contingency tables, or I'm sorry, conditional probability tables, and let's build one. Or they already have this first one built for us. So if a randomly selected person is a senior, find the probability that they are female. So this person is a senior. So we are looking at the title of seniors and the senior information only. So use that title to kind of help you see what's covered or what is revealed to you. This other stuff is not revealed to us. Not females, not all the males, just all the seniors. Now, if there's females or males within that column, we will use that information. Okay? All right, so find the probability they are a female. So out of these seniors, 7 of them are female. So this would be 7 out of 17. Now this next one, probability of junior given a male. So for this information here, they are giving us the information of the male students. Which of those that are given to us are juniors? In this case, that is going to be 5 out of 15. Again, make sure that you simplify that. I am not working on simplifying in this video, so you need to know how to do that piece. Okay? All right, next one. Probability of female or a senior. Now, this one has no given. It is saying that they are going to be female or a senior. So there's 2 ways to do this. One way is with the formula. The second way is just looking at the table. I'm going to practice with the formula because that's what most of you seem to understand during class. Then I will go over just looking at the table. So probability of a female plus the probability of a senior minus the probability of a female and a senior. So females, there are 10 out of 25. Seniors, there are 17 out of 25. And females who are seniors would be 7 out of 25. That there gives me 20 out of 25. Okay, remember again to simplify that fraction. Now, if you're somebody who would prefer to look at the chart instead and say, I only want to highlight those who are females or those who are seniors, highlight the females, highlight all those that are seniors. Now, this has nothing to do with the totals, and this still comes out to 20 out of 25. Okay? All right, let's go on to number 12. Probability of male and a senior. The ands are pretty easy to find. There is no givens. There isn't anything to subtract. We just need to look for the ones that are males and seniors. So here's the males. Here's the seniors. The only place they overlap is right here. So that's 10 out of 25. Alright, next one. What is the probability that a randomly selected person is male given they are a junior? So these ones here are given this information. So males given out of that column is going to be 5 out of 8. Alright, let's go on to the last section where we are creating our own table and then solving questions off of that information. So off this one here, a survey of 200 students at Adams School for the Arts revealed that 130 prefer classical music when studying over no music at all. There are 50 students that are left-handed, and of those surveyed, 13 said they are left-handed and do not prefer classical music. So 200 total, 130 prefer classical music, so that's another total. And there are 50 students that are left-handed, so that is the total for the left-handed. And 13 said they are left-handed and do not prefer classical music. So that is one of those 4 groups. So left-handed and do not prefer classical music. Now that's the information that they gave us. We've got to find that missing information. So if I've got here for the totals, I'm going to go ahead and go with the totals first. Let me get rid of this piece, sorry. Okay, so here I've got 70 students. Right here I have 150 students. 13 minus 70 gives me 57 students. Not left-handed who prefer classical music would be 93. And left-handed that prefer classical music would be 37. Okay. Once you have that table completed, you can answer the questions below. Given that a randomly selected student is left-handed, what is the probability that they do not prefer classical music? Given they are left-handed. So looking at this information here, and that is all I'm given. Okay. So they do not prefer classical music. That would be 13 out of 50. All right, the next one. A randomly selected student prefers classical music. What is the probability that they are not left-handed? So this one here, they prefer classical music. So the only information that I'm able to look at is this column. Or this row. So what is the probability that they are not left-handed? Well, not left-handed is 93 of them. So that would be 93 out of 130. All right, make sure you have any questions down before the test, and that way you can go over them with me. And again, you need to complete this test Tuesday or Wednesday after school or Wednesday during lunch.